Geotechnical engineering, laying the groundwork for a stronger tomorrow in civil construction. Hello everyone, I'm your host Dalvinder Kaur from Lovely Professional University. Get ready to dive into today's topic, that is introduction of geotechnical engineering in civil industry. Before we proceed further, allow me to introduce the experts of the day. Dr. Vaibhav Sharma, Assistant Professor, School of Civil Engineering, LPU. With over 7 years of teaching and research experience, Dr. Sharma is leading expert in soil structure interactions, sustainable waste reduction techniques, and more. He has supervised numerous students and published over 30 research articles in esteemed journals and conferences. So now, I would like to introduce the admission nominee also in this webinar, Mr. Rishabh Sharma, Officer and Area Coordinator at the Department of TIEPS, North 1 Division of Admission, LPU. Mr. Sharma plays a pivotal role in connecting the universities with various institutions and organizations. Before we proceed further in today's session, I would request to everyone, for any questions you can write in the chat box or in the Q&A box, and same will be addressed from my side in the end of this webinar. And now I hand over the things to Dr. Vaibhav Sharma, and it would be an absolute delight to listen from him. Over to you, sir.
Thank you so much, Mr. Vinderji. I'm very happy to be a part of this webinar series, and I'm sure the students or the audience who they are looking forward to this particular lecture, and it's going to be on geotechnical engineering, which is a sub-discipline of civil engineering. And just about to share my screen. I hope my screen is visible.
The screen is visible. You can continue, sir.
Thank you so much, ma'am. So, this lecture is about geotechnical engineering. Basically, I'll talk about, in general, what geotechnical engineering is. But before that, we must know that it's a sub-discipline of civil engineering. And so the topic is kind of an introduction to civil engineering and its sub-discipline, geotechnical engineering. So we, as a civil engineers, we all know, or whenever we hear about the term civil engineering, we always think about structures, big structures, dams, infrastructure, and everything. But most of us often forget about the role the earth or the rocks they play in supporting all of these structures, because there is not even a single structure which is not resting on a soil or rock. So it's very important for all of us as a civil engineers to understand what role does soil or rock plays, because ultimately they are going to support the entire infrastructure. So in general, these are some of the definitions of some technical terms that we use for soil mechanics or geotechnical engineering. So geotechnical engineering in general is a broader concept. It covers the mechanics of soil, the mechanics of rocks, and the applications of soil and rocks. So here, the mechanics term stands for how a particular material will behave whenever it is stressed. So, for example, if we want to construct any facility, it is going to be resting on soil, or it is going to be resting on earth. Now, the earth, we all know that it's made up of a mixture of rocks and soil, right? So, depending upon area to area, we'll find rock somewhere and we will find soil somewhere. Soil is just the disintegrated parts of rocks. So we try to divide this concept of geotechnical engineering into two separate parts. One is soil mechanics and the other one is rock mechanics. So if we're trying to understand the behavior of soil, whenever a structure is built on it, we call the behavior as a soil mechanics. And similarly, on the other hand, if the structure is resting on rocks, So we have to understand the behavior of how rocks are going to behave to these external loadings. So this is all about geotechnical engineering in general. So I'll not cover the more technical details. I'll just let you know what geotechnical engineering is in a broader sense. So if we talk about a basic geotechnical project, we know there is a construction site from means if whenever we want to construct any facility, uh, we it's the job of a geotechnical engineer to study the properties of soil. So what he does, he takes soil samples from the particular site, take those samples to the laboratory for testing. After testing, he'll get some properties of the soil, and by using those properties, the geotechnical engineer will again design or will give some probable foundation analysis, or means he'll do some kind of math here to come up with an idea that if we want to construct a particular facility, what should be the size of its foundation or the supporting structure. Once these processes are complete, only then the structure can be built. So it's a cyclic process. So I'm repeating again. So from a construction site, a probable construction site, soil samples will be collected. These samples will be tested in the laboratory. Based on their test results, a design will be done, and that design will be forwarded to the execution team, and that execution team will actually build the structure on the particular site. This is the basic, cycle of any geotechnical project. Now, let us see some of the applications of geotechnical field. So the very basic application is foundations. Foundations are what? They are the supports of the structure, and their role is to transfer the structural loads or the weight of the structure into the ground safely. Where the term safely means we don't want the foundation to break while supporting the structure, and we also don't want the soil on which this structure is resting to fail, right? So this term safely means neither do we want the foundation to fail, nor do we want the soil to fail. So for this, we need foundations. So again, the role of foundation is to transfer the structural weights or loads into the ground safely. So foundations could be of different types. So here I've shown a simple shallow foundation. So shallow foundation, as the name suggests, these are small foundations. The depth of these foundations are not very deep. You can see in this image, you can see these small rectangular blocks underneath this simple structure, right? So their depth is not up to the bedrock. I hope you can see these, uh, the soil profile here. So here, this zone, you can see a firm ground. This is made up of soil portion, and underneath it, you have a bedrock. And these small squares that you see here, these represents the foundations. So here, the foundation is shallow, means the extent of these rectangles, they are not up to greater depths. And these types of foundations are provided if the weight or the size of the superstructure, in our case, this particular house, is not too high. And this is the actual photograph showing the shallow foundation. You can see these foundations. These are the examples of shallow foundations. And I hope most of you have seen these shallow foundations whenever there is any kind of construction activity going on around your neighborhood. So if you see here, the shallow foundation. So this is an example of failure of foundation. And the example is from transcona grain elevator. You can see the figure on the left. uh, the structure is stable, but the figure on the right shows the structure has failed. In fact, you can see the structure has not failed, but the foundation has failed. You can see the structural integrity is still there, but the entire structure has tilted. So this tilting means foundation has failed. And this type of failure is known as the bearing capacity failure, or in the other terms, the foundation was not able to support this structure. The weight of the structure was very high for the particular foundation. So it means we need to understand foundation systems. We need to be very careful while designing these shallow foundation systems. And this is another example of foundation failure. It's not kind of a failure. We can say it was reaching a failure until the engineers had stopped this particular failure from happening. And this type of failure is known as differential settlement. You can see this tower, which is inclined. It's not perfectly vertical. It is inclined with the vertical. So this inclination shows that there is differential settlement. Differential settlement means one end of the structure settles more as compared to the other end, right? Now we have another types of foundations, which are deep foundations, and these are required if we want to avoid these types of failure, because here in this case, the foundation was incapable of supporting the structure. It means we need to do something to support the structure. So instead of providing shallow foundations, we can provide deep foundations. Right? So deep foundations. So the role of deep foundation is, again, it is similar to shallow foundation. They will support superstructure and transfer the loads safely into the ground. But in this case, the loads are transferred to deeper depths, up to the bedrock. You can see here these vertical lines. These vertical lines represent the foundation of this structure. And you can see the extent of these vertical lines, it is up to the bedrock. So means the load of this superstructure is directly transferred to the bedrock here. And these vertical members, whom we call piles, whom we call foundations, are known as piles. So these are vertical cylindrical members. These are very slender members, and their job is again to transfer the load of superstructure into the ground safely without failing. Means these vertical members will not fail. Additionally, we don't want the soil to fail on which these members are installed. Then these are some of the ways or methods by which we can install these foundations. We can use driven piles. Right? Means again, I said these are vertical members. You can see here a small image of a cylinder looking pile. So these could be pre-installed or not pre-installed. This could be pre-casted, means a term which is similar to ready-made, or we can make them on the field, right? So for driven piles means the piles will be driven into the ground. For driving these piles, we need to have piles with us beforehand. So if the method used for installing the piles is driven piles, we'll use the pre-casted piles or ready-made piles. We'll construct these piles in the casting yards, and from there we'll transfer these piles to the particular site location. And with the help of these machines, we'll simply insert these piles or drive these piles into the ground at their desired locations. And these are some other examples of driven piles. Here, these are timber piles. Okay. So now you must be wondering that I've used the term timber piles here. So depending upon the type of the material that we use, piles can be classified. These foundations can be classified. So these could be made out of concrete, which is basically a mixture of cement, sand, and aggregates with water. These could be made of timber, as we can see here, or we can use steel piles. It depends upon the designer, and it also depends upon the cost availability. Then if we want to install piles or cast piles into the ground itself, means we don't want to use ready-made piles. We want to construct pile in its place of location. So for that, we need drilled shafts. Means we first have to create a borehole into the ground, and then we'll insert the reinforcement, which are made up of these steel bars, which will be tied together, and then we'll fill that hole with concrete, which is basically a mixture of cement, sand, and aggregates with some moisture or water content. Then another application is the retaining walls, and their object is to prevent soil from spreading laterally, right? And these are mostly used in underground constructions. You can see here these vertical members, these are known as retaining walls because on the outer side, you can see this brown color. This brown color represents the soil. So these are basically trying to support or trying to prevent the lateral spread of the soil. If they are preventing the lateral spread, obviously soil will exert some lateral forces. Right? So these members will be called as retaining wall because they are retaining soil on one side. Okay? And another example of retaining wall is in the hilly regions. Whenever you go to any hilly region and you're going through a road, and you will see on the hillside that there are some walls constructed, and their object is simply to prevent the flow of hillside soil. So they are also protecting the movement of soil, which is on the hillside, which is on the higher side. Those are also retaining walls. So again, the objective of retaining wall is simply to prevent lateral spreading. And these are very common these days in most of the highways. You will see these retaining earth walls. So the retaining earth walls. Here the term is retaining wall. Here it is retaining earth walls. Earth simply represents soil, the soil. If the wall is retaining soil, we call them earth walls or retaining earth walls. Right? And here the term is reinforced. Reinforced means if you see here in this image, you can see only soil here. You can see only soil here. But this soil is not reinforced. Reinforced means we're not adding anything other than soil to increase the strength of the soil. So the objective of including reinforcement in soil is to prevent its lateral spread or stop its or minimize its lateral spread. So for that, sometimes we have to include some reinforcements. Reinforcements could be in the form of sheets, could be in the form of grids, etc. There are so many ways by which we can include or add some additional reinforcements or elements which would prevent the lateral spread. And the technical term that we use for those reinforcements is geosynthetics. Geosynthetics. We use geosynthetics. There are different types of reinforcement. There is not only one single type of reinforcement. There are multiple types of reinforcements, and sometimes we use them for some other purposes like containment. We'll discuss all these things later in this lecture. So retaining wall means they are simply retaining the earth, and reinforced earth walls. They're also retaining earth, but this time the soil or earth is reinforced with members. And then we have this cabin walls. These are also similar to retaining walls, but here we have these blocks of, you can say, panels, right? So you can see here, we'll first, add all these, you can say, locally available gravels or big chunks of rocks in a cage, right? cage, or you can say a mesh. So once we add all these to a mesh, we'll make a simple panel or simple cube. A cube will have some length, some width, and some depth. So we'll make a cage out of mesh. We'll fill that mesh with these locally available gravel, and means we'll have a bigger sized an element which is similar to a brick, but it is contained inside a mesh. And then we'll place these members over one another and will make a continuous wall. You must have seen these walls on hilly regions, on highways which are going through hills. And their again objective is to protect the lateral spread or stop the lateral spread of soil to prevent the landslides. Lateral spread is actually happening because of landslides. Then we have tiebacks. This is another way of providing the retaining structures. So tiebacks are simply we're inserting some nails into these walls, and they are going through the soil. They're they're going through this wall, plus they're going into the soil behind the walls. So by doing so, it will increase the density of the soil. It will increase the density of soil. By increasing the density of soil, the lateral spread of soil again decreases. So this is the purpose of providing tiebacks. And this is again similar to tiebacks. Here we have soil nailing. In this, we'll simply insert nails into the ground, into the walls. You can see this very big wall. This is again a retaining wall. It's retaining earth on the other side. And we are inserting these members. You can see this pipe looking members. These are nails. These nails will be pushed into this wall based on the design and criteria. And then it is obviously they will increase the density of the soil which is getting retained. The difference between soil nailing and tieback, there will be a difference. In this tieback, you can see it's tied over here. The number of different nails which are or wires which are inserted, and then they're tied together. But in this case, there is no such time. We're simply pushing these rods into the ground, and then we're covering the hole with the ground. Right? The difference here in tieback and soil nail is tiebacks are they are tied. Soil nails they are not tied. And sometimes we use excavation support systems to protect the lateral spread, and these are temporary. These are temporary. And these types of systems are basically used in urban areas when there are very big buildings nearby and we need to do some kind of excavations. And obviously, if we do excavations before without providing these excavation support systems, the sides of the walls would cave in, and it's very dangerous to the working people inside the excavated region. So we want to protect these vertical sides from caving. So for that, we provide these excavation support systems. And one more type of retaining system is sheet piles. These are similar to piles, but these are sheet. Okay? And their purpose is simply to retain water on one side and earth on the other side. And depending upon the type of material, they could be of steel, they could be of timber, and they could be of concrete. But we avoid providing concrete sheet piles because because of water movement, we want the structure to be slightly flexible. And concrete is not that much flexible. So for that, we generally use steel and timber. These are some other examples of sheet piles. You can see water on the other side, and here water level is different, right? So from both sides, the water level is different. And these sheet pile walls, these are for temporary works only. These are not permanent structure, these are temporary structure. So in case we want to construct anything in a river body or a water body, we first use sheet piles, and then what we do, we pump out the water from the center so that the bed of the river or water body gets exposed, and then we can do the construction procedure. Once the construction is complete, we remove these sheet piles. These are some more examples of sheet piles. You can see the image on the left, the image on the right. These are all sheet piles. The next term is coffer dam, which is an improvement or the other name for sheet pile homes. So coffer dams or dam, it is similar to dam. So the objective of dam is to have a reservoir on one side. So these sheet pile walls, these means when we provide a sheet pile wall, you can see here. This is under construction. Coffer dam is under construction. We have a sheet pile wall here. We'll provide sheet pile wall here. We'll provide sheet pile wall here and also here. Okay. And then this assembly will be shifted to water body. And then it will be placed inside the water body. And then we'll remove the water from the center by using pumps so that the bed gets exposed. We'll do the construction activity. Once the construction activity is over, we'll dismantle this sheet pile walls. Means when sheet pile walls are used to enclose a particular area, we call it a coffer dam. If sheet pile walls are not used to enclose an area, we call them simply sheet pile walls. Then another application of geotechnical engineering is in tunneling. Right? Tunnels, which are underground conveyance systems. The tunnels may be used for the transport of water, the transport of you can say vehicles, the transport of different things. And these also come under the geotechnical field. Then another application of geotechnical engineering is earth dams. So the objective of earth dam is to simply have a reservoir on one side. And these dams are made up of earth or soil. So it's very important to understand the properties of soil here, because we don't want this water to pass through the dam or pass over the dam. So, therefore, this comes under the category of soil engineering or geotechnical engineering. Then another application is landslides. As a geotechnical engineer, we can do certain calculations, certain analysis by which we can predict that at a particular place landslides are bound to occur or not. So there are certain applications, mathematical procedures, coding provisions that we can use or utilize to predict the occurrence of landslides, and it's very useful. Then again, earthwork. Earthwork simply stands for we are transporting earth material from one place to another. Earthwork also consists of excavations, filling, and we generally use it in road work and highway works. Then we have some certain geofabrics. These are used for various purposes. We can use them as a reinforcement. If you remember the retaining wall system, in the retaining wall system, we said we can reinforce the soil. And the objective of reinforcement is to restrict the lateral movement. Right? So we can add reinforcement. Here you can see this white colored fabric. We can use this as a reinforcement. We can use this as a separation. Separation means in the soil, we'll have different sized soil grains. Like we have sand, we have gravel. While during the construction of road, if we want to keep sand and gravels separate, we need a layer in between. For that, we provide this fabrics. We call them geofabrics. And these can also be used as a filtration, as these are made up of kind of synthetic material. So these can be used for filtration. Means water can easily pass through them, but the soil grains will not pass through them. These can also be used to the drainage in roads. Sometimes the roads become impermeable, means without the provision of these fabrics, the gravels and sands, they will mix. And what will happen? The sand grains will fill the voids present in the gravel, thereby making the mixture of the soil more dense. More dense means the volume of space for voids in between soil grains will be very less. So it would be very difficult for water to move through these small voids, right? So if we provide these fabrics, and by providing these fabrics, we are separating finer material from coarser material. It would be very easy for water to pass through because the finer material is no longer able to fill the voids of coarser material, and they are working separately. Similarly, we can use these geofabrics in retaining walls and embankments also. These are geosynthetics. You can see these are three-dimensional reinforcing elements. You can see some pockets here. These pockets are formed. We call them geocells because these are different cells. So these are geocells. We fill these cells with soil, right? And eventually, these small cells will prevent the lateral spread of river. So in general, the provision of reinforcement is simply to prevent the lateral spread of soil. And these are mechanically stabilized earth falls. These are similar to reinforced earth falls, which we have already discussed. Now, this is a new introduction to geotechnical engineering, which is an addition of environmental engineering and geotechnical engineering. We call it geo-environmental engineering. So it's a new addition to the field of geotechnical engineering. So in this, what we do, we try to characterize and remediate some kinds of hazards. Example is municipal solid waste landfill. You can see this image to the right and this image to the left. If you see the image to the right, you can see the situation is very bad, and these drums they are covered with different chemicals, and these are placed in open ground. Now, can you imagine, as whenever it rains, water will fall over these toxicated drums, and then as it is resting on open ground, water will seep through the ground, and there are chances that this water might come in contact with the groundwater, which is the only source of drinking water, right? So what will happen eventually if this water, the rainwater comes in contact with this system and it gets seeped into the ground and ultimately coming to the into the contact with groundwater, it will contaminate the groundwater. So we don't want the groundwater to get contaminated. So for this, we need to first understand how much contamination is there, what type of contamination is there, and how to prevent this contamination from spreading. So for that, we have introduced this new field in geotechnical engineering, which is known as geo-environmental engineering. And again, the objective is we first identify what types of chemicals are there, which is characterization. And if they're harmful, then we need to remediate these issues. We need to do something, restrict these contaminants from spreading into the ground and ultimately reaching the groundwater. And this is again a part of geoenvironmental engineering, which is this image shows an example of a municipal solid waste landfill. So if you see in this image, this is the groundwater table, the groundwater which is present in the earth. Above it, we have soil, and this white portion, right? This white colored area is your municipal solid waste. Municipal solid waste. And we don't want this municipal solid waste to be placed on ground like this. We want this entire thing to be contained in a particular engineered facility. So this engineered facility is known as engineered landfills. Right? So here you can see there are different layers. The objective of these different layers is to prevent the leachate which is getting generated from the decomposition of your municipal solid waste to come in contact with this soil and to this groundwater. We don't want this. So for that, we need to contain this entire thing in a closed container. So obviously, this is not a container. This is made out of natural materials. We generally use clay here, which is highly impermeable. So we have to use different layers of soils. We may have to use geosynthetics. And again, the objective is we don't want the decomposed leachate to come in contact with. Plus, we don't want the decomposed material to come in contact. So I hope all of you know that if the municipal solid waste is getting decomposed, it will release large amount of methane gas. Right? And there are some foul gases also. So obviously, the people living near to these sites will get affected. So therefore, we want to cover this on the top. We want to cover this at the bottom. So this is an example of landfills or engineered landfill. Then comes the instrumentation. Instrumentation means the different testing equipment that we use to get the properties of soil and understand the behavior of soil, all these things. So objective is to monitor performances of earth and its supporting structures. Earth stands for the soil, and its supporting structure could be the foundations, etc. And other objective is to measure loads, pressures, deformations, and strengths. So these are some devices that we use to monitor the performance of these geotechnical structures. For this, we need to do some soil testing. Right? Soil testing, these are few examples. One is vein shear test, second is standard penetration test. These are some typical geotechnical tests which we conduct to check the load carrying capacity of soil. So once we conduct this bone penetration test, we'll get some information like this, which we try to comprehend in a more general, readable, and understandable way, so that the execution team could understand it. And this is another test which we conduct on soils. This is known as triaxial test. Now comes to the challenge part of the different types of hazards that geotechnical engineers may face. So the first type of hazard is how will the groundwater condition impact the engineering project? So a very good example is Teton Dam failure, which was taken place in 1975. Because of groundwater fluctuations, the water level behind the dam, it falls rapidly because of that. Because of that rapid drawdown, the properties or the behavior of the structure was not assessed during the design phase, and therefore this was a catastrophic damage. Another example is what will be the impact of excavations, grading, and filling. Right? So means if we do excavations nearby any existing structures, there are chances that the existing structures may get affected. So we need to understand this concept also. We cannot do excavations nearby any existing structures. Excavation means large excavations. So always try to avoid these large excavations. But if there is a need of large excavation, you must consult a geotechnical engineer first and check his guidance that whether excavation is possible. Obviously, he'll provide particular certain solutions that whether this excavation or how to do these excavation, what type of excavation support systems be required. One more hazard case, the natural or proposed earth slope, whether it is stable or not. For example, the landslides. Most of the rainy season, we hear that landslides are a frequent phenomenon. So it's because of the presence of water in the soil, which kind of increase the lateral spreadability of soil. Or in other words, it will reduce the strength of soil. If the strength of soil is falling, obviously the soil will fail. Landslides are a kind of failure of soils. And obviously the effect of natural phenomena like earthquakes. Because of earthquake, if the geotechnical studies are not done properly for any structure, the result could be like this in these two images. You can see the structural component is very good. Structural integrity is there in both of the pictures. But you can see very clearly the entire structure has tilted or fallen. Which means the soil or the foundation we have failed. Failed. Why? Because there was no prior geotechnical studies conducted on these soils. Or if the studies were done, they were not done very properly. These are a few more examples of carelessness of geotechnical engineering. This Kobe earthquake and the Chichi earthquake. Most of these earthquakes, and due to lack of geotechnical experts, these kinds of failures took place. Now, what are the solutions? If these kinds of things are there, what are the solutions with this? We can means obviously soil is a material. Every material has a threshold capacity. If the threshold capacity is reached, then how to prevent the failure from occurring? So for that, we have solutions. We can go for ground improvement. Ground improvement means, in this case, we're using an impact roller. You can see these rollers. The objective of these rollers is to compact the soil. After compacting, what will happen? The soil grains will come closer to each other, making the soil system whole as a denser system. So more denser the system, more strength the system will offer. Right? So we can use different types of rollers. So depending upon the type of soil, you can use different types of rollers. So these are compaction techniques. In this image, you can see these are tamping techniques. Very big weights, they are lifted and dropped onto the ground. And you can see these craters are getting formed. Right? These craters are getting formed. And here also in this image, these craters are getting formed. So it's clear that the soil is getting compacted. The soil grains are coming closer to each other, thereby making the system a denser system. And obviously increasing the load capacity of this soil. Another way of improving the soil is using stone columns. Right? So what we do, we'll make a borehole, we'll start to add stones in it, we'll compact those stones. Right? Means initially it was soil alone, whose strength was weak, and we want to improve its strength. We reached to this stage. There was a hole, we made a hole, we filled that hole with stones, we compacted those stones, thereby increasing the density of the soil there. it will increase the load carrying capacity. Now here in place of stones, we're using cement. Okay, we're using cement. Is grouting, creating a hole and the soil. Then one more compaction technique. Okay, we can use these nails to increase the compaction or increase the density. We can insert some admixtures like this and like this. So again, the objective is to increase the density of soil. We can also use chemical injections. We can inject different types of chemicals to improve the load carrying capacity of soil. Right? So it means we have some ways by which we can increase the strength of the existing ground. So by improving these strengths, we can make the construction of different structures possible. So therefore, we shouldn't wait till the last minute, because once the structure is constructed, it's impossible. It's very difficult to improve the soil properties. But still, there is a way to improve the soil properties even after the construction of structure. But that doesn't mean we are not consulting geotechnical engineer before the construction. So it's always advisable to consult geotechnical engineer before starting a construction, that whether I will be able to construct my facility over here in the existing conditions, or do I need some kind of modifications? So this slide is instability terrains like landslides. We can use retaining walls here. We can use some dams. We can use as a foundation of structure. We can use them on embankments, some water tanks. We can use them in marine structures, and we can also use geotechnical engineering in oceans. Right, so it has a wide range of applicability in terms of infrastructure. So all of these structures, they all are resting on a pyramid, obviously. So we need to understand behavior, and these are some of the geostructural engineers. They need the input of geotechnical. Similarly, transportation engineers, they also need the input of geotechnical engineers. Construction engineers, environmental engineers, earthquake engineers, hydraulic engineers, mechanical engineers, and geology engineers. Right? So from this particular lecture, I hope you get an idea that geotechnical engineering is very important aspect of civil engineering. Civil engineering is not only about the big structures, it is also about the soil, which is invisible to everyone of us, because the role soil plays is very important. It is actually the support of any structure. If the support is weak, the structure will definitely fail. Right? So we, as a civil engineers, we believe in hard work, and we also play hard. So that's it from my side.
Thank you so much, Mr.
Yes.
Vaibhav. So it was wonderful delight for discuss on typical geotechnical projects, shallow foundations, deep foundations, foundation system, retaining walls, retaining structure system, earth dams, and many more. So now I would request to the admission nominee, Mr. Rishabh Sharma, to be on the screen. Over to you, sir.
Thank you so much, Dalvinder ma'am. And further, I would like to thank and pay my regards to Dr. Weber for such an insightful presentation. I hope my screen is visible, ma'am.
Yes, your screen is visible. You can continue, Mr. Rishabh.
Yeah. So thank you so much. And Today, we will be discussing about accreditations and approval apart from this infrastructure part and the extracurricular activities and the exposure available at Lovely Professional University, along with the eligibility of BTech Civil Engineering, fee structure, scholarship, and important dates. So, without wasting much of time, I would like to give you glimpse of each and everything. uh, Firstly, it gives me immense pleasure and it gives me a proud feeling to announce that with and share with you all that LPU is now NAC grade A plus plus university with 3.68 score on 4-point scale, and it is highest score in first uh, cycle of accreditation among all government and private universities. And further, we have approval from ICAR, UGC, NCTE. We have approval from Council of Architecture, Pharmacy Council of India, Bar Council of India. List is long. We are also member of Association of Indian Universities, International Association of Universities, and list is long. You can have a look. If we talk about ranking, LPU has been ranked 23rd by the World University Rankings 2023. Uh, if we talk about, we have been ranked second by World University with the Real Impact ranking under the Atal ranking of institutions for innovation achievements. We have been ranked third. If we talk about exposure, LQ students created history. Uh, 12 out of 13 students won Olympic medals in all three categories: gold, silver, bronze, and yes, further, if we talk about extracurricular activities, music, fine art, dance, literary, theater, possession, LPU is overall champion for of 37th National Inter-University Youth Festival under ages of Association of Indian Universities, New Delhi. Moving further, first runner-up for Maulana Abdul Kalam Azad Sports Trophy 2023, which was awarded annually by the Ministry of Youth Affairs and Sports, Government of India. Further, 19th Asian Game bringing laurels to the country as well as LPU. Abhishek, our student, won gold medal in archery. Neeraj Chopra, gold medal in javelin throw. You can have a look. See the kind of exposure we are offering at Lovely Professional University. Indian Science one and LPU successfully hosted 106 Indian Science Congress, and it was inaugurated by Honorable Prime Minister of India. Moving further, His Holiness Dalai Lama in LPU campus, and you can see two former presidents sharing the same stage alongside our worthy Chancellor Sir Dr. Ashok Kumar Mittal, Member of Parliament Rajya Sabha, uh, then former Prime Minister of President of Afghanistan, Mr. Hamid Karzai, former President of India, Mr. Pranab Mukherjee, then Finance Minister of India, Shri Arun Jaitley, Venkaiah Naidu ji, Gohar Gopal Das, many Bollywood and sportsmen also visit LPU campus. You can have a look. Shah Rukh Khan, Deepika Padukone, MS Dhoni, Sonam Kapoor, Prabhu Deva, Sonu Sood, Ranveer Kapoor, Akshay Kumar. Very interesting. LPU holds a Guinness World Book of Record on its name for highest number of persons doing Bhangra at a single venue. Moving further, this is the uh, infrastructure of LPU. You can have a look at state of art infrastructure, indoor stadium with capacity of more than 2,500 people, labs, library, Unimall is there. You can get all your basic needs fulfilled from here, right from essential needs, gymnasium, bowling area. We also have a 50-bedded hospital in our university. lush green campus. You can have a look at our campus aerial view, and we have been awarded the Green and Clean Campus Award as well. So this is the night view of lovely professional university. We do have indoor stadium facility as well. Badminton courts are there, shooting is there, basketball, volleyball, squash is there, Olympic size swimming pool is available at LPU, and this is the outer view of indoor stadium. Now let's go live and discuss the eligibility part, fee structure. Just give me a second. Yeah, I hope my screen is visible. Now you might be thinking that how you can check all these details. For that, you need to go to www.lpu.in. When you will go to www.lpu.in, you need to go to admissions. From there, you need to click on 12, and then under 12, you need to select your discipline, that is engineering, right? Under engineering, these are the specializations, the streams we are offering. So we are talking about civil engineering. I have selected civil engineering. Now there are two options available. One is BTech Civil Engineering, 4 years degree, 8 semesters are there. But then we have BTech in Civil Engineering, 2+2 with international credit transfer option. Here what extra is there? 2 years you will be studying in LPU and will be paying in Indian rupees. And for next 2 years, you will be studying abroad with our partner university. Your credits will be transferred to that particular university. And in addition to that, you will be getting your degree, final degree from that university from abroad only. So let's select BTech CSC, BTech Civil Engineering. So eligibility says you need minimum 60% marks in 10+2 with English, chemistry, mathematics, and physics as your subject. Apart from this, you need to qualify either LPNEST or CUET exam. Now, what is LPNEST? LPNEST is Lovely Professional Universities National Entrance and Scholarship Test. You can give this test for your eligibility, and on the basis of this test, you can get scholarships as well. Now, let's talk about the fee structure of this particular program. Fees for this program is 1,40,000 per semester. There are scholarship on the basis of LPUNS, on the basis of 12th marks, on the basis of JEE main percentile. You can have a look. You can get up to 50% scholarship, that is 70,000 rupees per semester scholarship you can get. And if we move further, we also have scholarship on the basis of CUET. We have scholarship for board toppers. If you have any scholarship based on innovation, startup, or entrepreneurship, we are also offering need-based scholarship. We also offer financial aid for serving retired defense personnel, CRPS, CAPS, paramilitary personnel, and their dependents. We have financial aid for orphans, to persons with certain disability. And moving further, if we talk about the important dates, online registration for LPUNEST has already started from 1st April. Slot booking for examination has started from 6th April. Last date to apply for LPUNEST exam is 25th of April, and date of exam would be 15th April to 30th of April. Result will be announced on 4th of May, and there will be online counseling and seat allocation round. So between 4th May to 6th May, you need to fill your online seat preference. Then on 8th May, you will be uh, provided with your seat allotment letter. Result of allotment would be announced on 8th of May, and the date of admission for you would be 8th May to 15th of May. Between this time period, you can get yourself registered into BTech Civil Engineering. So now how to apply for LPUNEST? Firstly, the fees for LPUNEST is 500 for female applicant and 1,000 rupees for male applicant. To apply for this particular program, you can simply click on apply now. Otherwise, you can note the direct link, that is admission.lpu.in. Here you need to register yourself. Once you register yourself, then you will be able to apply your LQNest. And once LQNest is applied, I have shared the dates and details with you. And now if you want to connect with us further for further queries, you can schedule a call from here. Otherwise, you can chat with us on WhatsApp. WhatsApp number is 985256900, or you can simply click here also. And then if you want to have face-to-face live video counseling with us, you can simply click here and join us to Zoom meeting, and you can get your doubts cleared on video call as well. So if you want to connect with us through telephonically, this is our landline number 01824 404 404. You can simply call on this number. I'm repeating it for you, 01824 404 404, and you can get yourself counseled telephonically. So I hope I have cleared I have covered all the important information. So thank you so much, ma'am, for giving me this opportunity to guide the students. So all the best, students. Thank you so much, ma'am.
Thank you so much, Mr. Rishabh. As I can see, there are some questions from our participants. Can we take questions, Dr. Vaibhav?
Sure, sure.
Yes, sir. Gurpreet is asking, what are the key factors considered in... Hello, Dr. Vaibhav, are you there?
Yes, ma'am.
What are
Yes,
the key
yes, ma'am.
factors considered in
please.
geotechnical engineering when assessing the stability of construction site?
Okay. So it's a very good question, first of all. So the key factors to understand or to check the stability of any construction site from the geotechnical expert point of view is we must know what different types of soils are there. Means we need to know depth wise of different layers. We need to find out how many types of layers soils are there. And we need to find out their properties. For example, how much dense they are, what are their strength parameters, where is groundwater table, and in addition to this, we need to find out if there is a presence of any contaminants. So keeping all these factors in knowledge, we can do some kinds of additional testings. And based on those testings, we can design or we can tell whether the particular site is sufficient or stable enough for the construction or not.
Thank you so much, Dr. Vaibhav. I hope, Gurpreet, you got your answers from our expert. As we come to the end of this webinar, I want to express my deepest gratitude to our experts for sharing their valuable insights and expertise with us. Your presence, enthusiasm, and active participation have made this experience truly special. Hopefully, the attendees found this webinar to be valuable and will be able to utilize the information for better decision making regarding their admissions. If anyone want to access this webinar again, they can visit our website, that is lpu.in, or can be accessed on the YouTube also. Stay connected with us for future webinars. Until we meet again, with the permission of my seniors, I would be signing off this webinar. Take care and goodbye. Have a nice day.